Okay, by the way, have you checked the quiz? Okay, you can work out the quiz. Okay, don't forget that we will have a deadline for the quiz. And for those of you who are submitting the quiz already, I think maybe from yesterday or 2 days ago, I will adjust some scoring system because there is some questions that I think I wrote um, not in clear description, so I will adjust your scoring, okay, so that you will have more points on one or two questions. Okay? I have fixed the questions though, so if you are working after this, it should not be a problem for the questions. Okay. Okay, so for today's lecture, we will like to start with the this is the 15.5. I will just to give you some quick review summary on what we are having in the surface area. Okay. So this is a surface area, which means that we are going to evaluate, like for example, if this is the case, if number one or number two, they have the pictures, so it's easy to explain, which means that we are going to evaluate the surface area here, okay, this red color here, which means that we are going to have the same region as we did in the double integral. So we did this D, okay, this V region that is projected from the surface going down. So for example, if we see this number one, okay, the first thing is we have the surface, right? We have the surface equation, which is our z, right? Or our function of xy here. What's the purpose of this function? This function is in particular is we can find the relations with the tangent plane, right? The tangent plane. So we could imagine a small tangent, like in the small pieces, like we did when we prove what is the surface. That is, if we take this tangent plane here and we add in all directions along the surface, then we could calculate the surface area. Okay, so the first thing we could do is we need to find the component of the tangent plane, okay, which is the partial x and partial y, and that is the component that we need to take down the surface area. Okay, so first thing, let me write the z is, what is the functions? 10 plus x plus y squared. Okay. Now let's say we have a functions of two variables is z. Okay. Let me write again, and we can write down the partial x. This is 1, right? And the partial y. This is 2y. Which gives us a slight idea that is the surface supposed to be this, let's say the D, and then the surface area is the let me just write partial x first, and then partial y, and then plus 1, and then dA. Okay, now let's put on all this information into the surface area. Let's keep this D for a while. Okay, we haven't yet looking up the D, the region. Partial x is 1, plus 1 is 2, partial y is 2y, squared is 4y squared. Okay, let's say it's dA. Okay. Now then, we have the vertices, okay, for the D. Okay, if we look the vertices, we could have on xy the vertices right here. Vertices of D is 0, 0, right? And then 2, negative 2, and then 0, negative 2, right? Okay. Or if we would like to draw, to draw the D, if you want to sort of the some confirmations, what will be in our region D. This is 0. Let's say this is 1. It should be -2. Maybe I will stake this a little bit here. So 0, 2, -2. So we will have 0 here, -2 is here, so we will have here. So that's our D. Okay, so we could see that we take Y, it starts from 0 to -2, and if we take X, we have Y equal -X here, right? So we could take X is from 0, right? From 0 to -Y. Okay. And now another thing in the surface area is we know that the function inside here is y, right? So I think it's better to go for dx first and dy. Okay. That's why I start the constant through y-axis. Okay. Now we could write down this is -2 to 0, and then 0, -1. Yeah, it's wrong here. Sorry. It's supposed to be -2 to 0. And then we could take the integration with x and then take integration with y. So we take the integral inside. So we could have -y and then y plus 2 plus 4y squared dy. Okay. And I believe you can solve this through some substitutions. Okay. So you could substitute. So we could just take 1/8. Okay, 1/8 minus 1/8. And then this is supposed to be square root of u like that. So we could have 2/3, 2 plus 4y squared, and then half plus 1 is 3/2 from -2 to 0. Okay. I think you could just take some time to check. Okay. This is supposed to be cancel this. It's supposed to be 12. And let me just switch the other way around. So I will take -2 inside. And it's supposed to be 18, 3/2 minus 2, 2/3. And you can simplify, it becomes 13. Okay. So that's the what we have. Okay. So the idea is to take the surface, take the partial x, partial y, and then you can take on the surface area. Okay. So you can, maybe if you want to write some notes about the surface area. Okay, I think we can continue. Okay. Okay, perhaps the other type of questions, like you see here, I believe you could check it out by yourself. The idea is still the same. Uh, that is, you are going to be using the partial x partial y. But for some case, okay, like the case in like number 3 here, remember that this is the plane. Okay, this is the plane, which means if we let this as if we let z as a function of xy, then we could rewrite this as this, right? And remember that if we have z, okay, then this, I hope you remember the tangent plane that is this formulations, right? Sorry. So the idea for the surface is we take 5 as partial x, we take 3 as partial y, okay? And then the other also same, but remember it has 2, which means you need to divide by 2, okay? And yeah. Okay, and yeah, I think that's quite understandable. Okay. Another uh, another questions that probably you still have maybe need more exercises on these transformations. Okay, it's on the 15.9. 15.9. 15.9 number. I think this is from the review. Okay, you can look up the questions first. These two questions. And check the result. And number 57 is quite a tricky one, the number 57. But you could check, okay? You could check. You could check it out. Okay, and do you have any problem on the quiz if you have taken the quiz? Is the platform working very well? Is it working? I think it's okay, right? And how do you think about the questions if you take if you have already taken the quiz? And I hope you are working by yourself, okay? it should help you to at least to understand uh, the work, okay, the works, and understand the topics. Okay, so we have three variables, okay, 3 by 3 transformations for Jacobian for this number 56. Okay, so first is look up the x. Okay, we have so we could rewrite the Jacobian, okay, for x and u, okay, and y and phi, and z and w. Okay. Okay, now the surface square root of x plus square root of y plus square root of z equal 1. This will be the region, okay, the region, let's say the region E. Okay. But let's start with the Jacobian first. Jacobian. So Jacobian x, y, z, u, v, w. So practically, because we have each variable 1, 1, 1, 1, 1, right? It doesn't correlate with the other one. So perfectly we have 2u, 0, 0, 0, 2v, 0, 0, 0, and 2w. Okay. Okay, if we solve this, we get that it is exactly has 8uvw, and then the other part will be 0, right? So this is our Jacobian value. Now the volume is triple integration with the region E and then dv, right? Now our region is, if we take square root of x plus square root of y plus square root of z is equal 1. If we exchange this into u, v, and w, x become u squared, so it's become u plus v plus w equal 1. So we could have, like in x, y, z, and z is a function of two variables, we could make this w as a function of two variables of u, v. So we could make w is a function of u, v, which is 1 minus u minus v. Okay, we could make that. And also we could make the v is, also we have a correlation here when it's on the intersections, that we might have that phi is a function of u. Okay, so 1 minus u. And let's say we are start, or the outside the integrand is u, that is start from 0 to 1. Okay, we take this as our constant. Okay, now we could take this into our formulations that we could make from 0 to 1, and then for v is from 0 to 1 minus u, and also from 0 to 1 minus u minus v. We start all from 0 because this is practically it's like the coordinate planes, yeah. So we will start all with from 0, 0, 0. And Jacobian is 2u v w, and then the w, the phi, and then the So slowly we could start with W. So 8 UV W, or W squared, I will divide by 2. And then W squared is 1 minus U minus V squared, and then dV du. Okay. So we could start to multiply this. It takes time for this formulations. So this will be 4U 1 minus U squared V, and minus 8U 1 minus U V squared, and plus U V cube after some steps. Okay, and this will be dV, and then du. I think I will move all through the here. Okay. And we could solve this. Yeah, it takes time, and all the v, let's integrate. So it's become, after uh, some calculations, v becomes v squared over 2, and then plug in 1 minus u. This becomes v cubed over 3. This becomes v4 over 4. And we have 1 minus u 4 minus 1 minus u 5, and then du. And after that, we could have integration from this u. And finally, we will have the 1 over 3, negative 1 over 5, 1 minus u, 5, plus 1 over 6, 1 minus u, 6. Okay, it's 1 over 19. Okay. Yeah, it's a little bit take times to solve, but yeah, hopefully we could take them. Yeah, if you find difficult to multiply this, we could multiply as 1 minus u and minus v, and then take this as a minus b, okay? And then slowly you could get this result here. And this is just to show you the 3 by 3 example. Okay, let's try number 57, or if you have calculate number 57, you can write the results on the chat box. 1/3. Mm-hmm. Mm-hmm. Not really, not really. Okay, let me go through new page. Okay, just to okay. So first, maybe take this vertices into our picture to see at least how does it sketch. Okay, so this is 0, 0. Yeah, at least we have the let's say r, okay, the square. Okay, now to to make our computations simpler, and we could see from this part. Okay, this is let me name all the points. So 1, 1, 2, 0, and 1, -1. Okay. And you may see that this is y equal x, right? This is y equal x. Or let's say in the sense that we have y minus x equals 0, right? And y minus x is equal -2, right? And here is y is negative x, right? Y equal negative x, or in our case, y plus x is equal 0, and y plus x is equal 2. Okay, now what next? Now from this r, we could see that we have this y plus x and y minus x. So we could start with y minus x. Okay? We could reimagine as u, and we could have y plus x as p. And we could solve and find the relations between x, y, and u v. Okay. We could start from plus. Okay, so we could start from 2y u plus v, and y is half u plus v. And 2x, if we subtract, this will be negative 2x u minus v, or x is half v minus u, right? Or if we were to write v first. Now the Jacobian, dou x dou u is negative half, dou x dou v is half, dou x dou u is half, half, So we will end up with how. Now, from this transformation u and phi, we could write down the vertices for u phi. So y minus x 0, 0. So 0, 0, still 0, 0. 1, 1 becomes 0 and 2. 2, 0 becomes negative 2. Negative 2 and 2. And 1, 1 becomes 2. Oh, right. Negative 2, sorry. Negative 2 and 0. Right? Yeah. Yeah, this new u phi. Now, according to what we have here, this is a square, right? A square that starts with 0, 0. 0, 2 is here. 0, 2. And negative 2 is going to be here, or maybe a little bit going to the right. So this is negative 2, 0. And negative 2, 2, right? So we will have a square, so perfect square. So we are going to have a double integral. Let's say r, x, y, dA, and then 0, 2, and then negative 2, 0. The xy, we could have 1 over 4 phi squared minus u squared, right? And then Jacobian is half, and then du d phi. Okay, we could start with factorize 1 over 8. And then du, we could take integration with respect to u. So it's supposed to be negative, positive 2 phi squared minus 8 over 3 d phi. And this will become 2 over 3 phi cubed. And surprisingly, it's 0, right? Surprisingly, it's 0. We could have anticipate this 0 situation from this r. Okay? R symmetric about x-axis, and integrand is odd function of y, which means we have y equal x and y equal negative x. Yeah, this might happen. This is resulting in 0. Okay. Okay, I think we can move to the other sides. Okay. Okay, I will move to the next page. Okay. Okay, the next page I have prepared question for you. So this is the questions. Find the volume of the region in the first octant bounded by the coordinate planes. The plane x plus y equals 4 and the cylinder y squared plus 4z squared equals 16. So I will let you know. Please write the answer if you find. Let me give you a few minutes, at least 3 minutes, 4 minutes to try. And you could have seen the obvious. So you could take two methods to solve this one. First is take the usual integrations in the triple integral, solve the inside integral, and then the double integral outside, maybe you can convert to polar, right? You can convert to polar. Or you could take the cylindrical coordinates. Okay. Anyone find the answer? So the first octant means all positive value, right? All positive value. So first is perhaps just imagine what kind of cylinder this should be. So if we look at this y squared plus 4z squared equals 16, okay, then perhaps this is a little bit like an ellipse, right? Like an ellipse. So if we could imagine this, and if we take the perspective on isometric perspective, this is C, X, Y. So it's supposed to be the elliptical should be around here, okay, right? And we have X plus Y equal 4. So it will be X equal 4, maybe here, and Y equal 4, maybe here. So we will have a slicing there. So we slice through the cylinder. Okay, so slice through the cylinder, and this is the cylinder. Okay. Okay, imagine that that the cylinder is cutting. Okay, so perhaps we could state if this is on the first octant, then we are only just considering the area that is in here. Yeah, sorry, the area that is here. Okay, the positive one. It's not goes down below and not goes like through here. Okay, they just take this first room, right? The first having all positive. We could state, okay, if we want to make integrations, we could state that this, let's say this is the solid is E, okay, and we could have a dphi, that's what our objective, and we could start from the dphi made up from either the outside either x or y, because they have both 0 to 4. Okay, so I believe should be okay. But since we have y and z as the cylinder, that perhaps the one that is having much complexity is going to be the inside one. So let's say going to be the inside one is if we take this, okay, so let me write here. So we could take, if we take the, let's say we take the x, okay, dz and dy. Okay. Since we know that we could make up x and y through this formulations, 4 minus x or 4 minus y, we could choose. Okay, so I hope you understand that we can switch x and y because they are we can treat them like for a constant from 0 to 4. So they both have 0 to 4, it's the same. So we could start with 0, 4, either y or x. Let's say we try with y before outside integration. And for the inside, we have we could state from here. Okay, we could state from here. Let's say z. Okay, let's say z. So 4z squared is 16 minus y squared, and we could end up with the z is square root of 16 minus y squared over 4, or half 16 minus y squared. Let's just write this as a function, the z, okay, so function of y. So let's state in here that we have, I think, should. So half 16 minus y squared, okay? And then from 0. Y from 0 because it's in the first octant, so we could just take just only in the first row. Okay. And then for dx is 0 to 4 minus 1. So dx, dz, dy. Now we could solve the inside. And it will be 4 minus 1 dz dy. And since we have these equations, okay, 0, 4, and 16 minus y squared, if we could look on the elliptical equations that we have, y squared plus 4z squared equals 16. Okay. What should we do to make this into our polar situations, into our circular equations? Okay. First, we have 4. So suppose that y and z is having some having cos, some having sine, and then we need to make up this 2 to make our polars. Okay. So to make these 2 equal, we should write y as 2r cos theta, okay, and z as r sine. Okay. So that we could make up this 2 becomes 4r squared cosine squared theta plus 4r squared sine squared theta. So we could have our r squared is 4, so r is 2. So we could have a circle with radius 2 from this equation. Now, since we got r, then we could write the r from 0 to 2. And we could also write the theta because it's on the first octant. So we could just focus on a quarter, right? A quarter, 0 to pi over 2. So the whole thing here, we could exchange and write down the formulations for the polar. And the 4 minus 2r cosine theta from 4 minus 1. And then this will be r dr, oh sorry, 2r dr d theta. Okay. Now how we get the 2r? Now this is a little bit related to the Jacobian. Yeah, the Jacobian. Jacobian yz r theta. If you want to prove that this is 2r. Okay, and this will be end up with 2r. Okay, okay, and solve this. dr is supposed to be 8r minus 4r squared cos theta. dr, this will be 8 or 4r squared minus 4 over 3 r cubed from 0 to 2. And this will be, the volume is 16. 16. Oh, forget the cos theta. $32 right, over 3 cos theta, and then d theta. So we have 8 pi, right? Pi over 2, 8 pi, and then minus becomes sine, and sine pi over 2 is 1, right? So this will be the answer. Okay, 8 pi minus 2 over 3, this one. Okay. Okay, next question is this one, but let me just take uh, take times for you to let know the notes here. Okay. Okay, probably any questions? If not, we can look on the other one here. Other question. This is a tricky one. Okay. We take a I would like to know if you have taken the quiz, but I'm sure that not all of you have taken the quiz, but for you who has taken the quiz, I would just like to let you know what do you feel about the quiz. If you haven't, maybe you don't really need to answer. Yeah, should be one more options, but yeah. Okay. I think at least 3, 4, maybe 5, at least maybe around 5 students taken. Okay. Now you should realize that this quiz and also the final exam, because we are on online, okay, it doesn't mean that the quiz or the final will be having a standard like the same standard like in offline. I will make it a bit more difficult, and perhaps difficult because I will let you use all your, even your gadgets, calculators, books, notes. But just one more things that I think you need to be aware of. Okay? Uh, for the final exam, I hope you works alone. Okay, I hope you works alone, so that perhaps I will divide some groups. Okay, I will divide some groups. So different students, different types of questions. Okay, so that will be probably our finals. But the probability may be same, similar difficulty, but different questions. Okay, probably that will be. Okay, yes, yeah. I believe the last quiz that I make up. Okay, I think I will close the poll. Okay, I just see. I think uh, more than half that has taken my quiz think that the quiz is difficult. Okay. I hope the difficulty let you give you more idea, okay, on what you are going to emphasize on. Okay. Yeah, this is the result. So I believe uh, from all the students who has taken the quiz to think that the quiz is difficult, and I hope you did the quiz by yourself. Okay, it's okay if the quiz, if it is the quiz, it's like the homework. If you want to take by groups, it's okay. But I hope after you take the works, you can review and you try by yourself. You try by yourself again the same questions. Try to understand the questions. Okay? Try to understand the idea behind all the structures. Okay, all the process. Okay, step by step solutions. Try one by one. Okay? And if you did it by yourself, that's great. I'm really appreciate if you did it by yourself. Okay? Before finals, okay, please works by yourself. Okay? If I caught you discuss with your friends or in groups, I know some, I believe some students maybe using maybe line group or maybe using other group as well to discuss. Um, well, if I caught you doing that, um, then probably directly zero for all the total score, okay, for the finals. Okay? Just believe in yourself. Okay, believe in yourself. Have a confidence. Okay? And eventually, um, if you did like one time, you will have tendency to do it again in the future. So I hope you don't do that. Okay? And it will be really bad for your futures. Okay? For your future, if you want to be a good engineer, or if you want to be a good scientist, or you want to be a good uh, like good person in every field in the future, in the industry, if you want to go into the industry, um, you have a reputation to be hold on. Okay, so I believe you can do it. Okay, as long as you keep believing in yourself. Okay, now we have uh, this question here. Okay, now this question, if you have like piecewise defined functions like this f x y, we have two definitions. It could be a functions that have x cubed minus y cubed, etc. when the xy is not 0, 0. Before 0, 0, it becomes 0. This means that we need to check. First is you need to remember. Okay, we need to remember or utilize the uh, the definitions. Okay, continuity definitions in chapter 14. Okay, chapter 14. So first, they are asking finding the partial x, finding the partial y, which means that which partial x, which partial y. We might have two conditions. Okay, so let's just write these two conditions as our subject. Okay, so first, for xy that is not equal 0, 0, 0, okay, we could just take into our definitions in here, which is we have xy is x cubed minus y cubed over x squared plus y squared. Okay, so from this equation itself, we could take the partial derivative of x. Okay, so we could derive and we could use the uh, quotient rule, yeah. Or if you would like, we could take this and make a product rule also fine. You could have this. I believe product rule is maybe better. So 3x squared and then multiply with the x squared plus y squared. And it's supposed to be plus this derivative and x cubed y cubed, but this one is getting negative and negative, and then 2x, so we have negative 2x x cubed minus y cubed divided by x squared plus y squared, and then squared because it's derivative. Okay, maybe solve this a little bit and make it x squared plus y squared and then squared. So this will be 3x. Let me erase this for a while and make sure that I'm doing the right thing here. 3x squared, x squared plus y squared, and then 2x 4 minus 2x y cubed, and minus minus, so it should be positive. So we could have 3x4 minus 2 is 1, right? And then plus y squared x squared plus 3x squared y squared plus 2xy cubed. Okay, that's the partial x. The partial y, same thing. We are going to have negative y squared x squared plus y squared. I'm doing the product rule, this one. Well, you could also do the quotient rule directly, but I'm taking the product rule. Okay, so we have plus 2y 4 minus 3, so minus y with power of 4 minus 3 x squared y squared minus 2y x cubed divided by x squared plus y squared. Okay, now what's next? So this is partial x, partial y. For xy is not equal 0, 0. I believe I need to write in a new page because it's I need to have more page. Okay. So let's which one is the question? I forgot. This one, right? Okay. Now for xy that is equal to 0, 0. Okay. What will happen if we take 0, 0? Now we take this as in our limit definition. And since h, if we take the equations, if you take here, based on our definition, this will be h cubed, right? This will be h cubed over h squared, which is 1 over h plus divided by 1 over h, which is resulting in 1. Okay, be a little bit to the left, a little bit to the left. Okay, and similarly, we could take the partial y. This will be negative h cubed, h squared, and this will be negative 1. Okay. Okay, so we have done part A. Now part B, the question is asking whether the functions, the partial, is continuous or not at 0, 0. Okay, so based on our calculation, to check the continuity, what you need to remember is, so if partial x and partial y continues at 0, 0, okay, then the limit as xy approaching 0, 0, okay, for partial x, and limit same thing here for partial y. They are exist, and it should be exist, and their values should equal 1 and negative 1. So we need to make sure that the value 1 and negative 1 that we have from the definition of partial x, partial y, it should be available in all possible paths. Okay? Okay. Now, we need to check some path that might have some difference. Okay? Maybe we have some path that might have a little bit difference from the supposed to be the answer. Okay? So we take, let's say, along x equals 0. Okay? So we construct. Okay? So limit xy 0, 0, partial x, xy. So along x0, let's say we have a for, just to note that this is actually y, point on y. So take x0 and the variable becomes y. And we could have, okay, what we have here is, if we use this part here, and if we change x into 0, okay, what we have is y cubed, y squared, like that. Okay. And if the y is getting 0, then y over oh, wait. Why I'm looking here, it should be partial x. Sorry. Where is partial x? Oh, partial x is here. Sorry. Okay. Now if we take here, so x equals 0, it should be 0, right? And it will be 0 over y squared, so y4. So 0 over y4. So this one, okay, this one should be 0. 0 over a4. That is 0. Okay. And same thing with the other part. If we take y equals 0, we take the partial x as, let's say, limit b, okay, for the other way around. Well, it should be, b should be which should be y, right? But let's whatever. But it should be, understand the idea behind this. This is also, if we take y, okay, what's y here? So if we take y equals 0, all will be 0, right? Y is 0, right? So we could have 0 over b over 4, which is 0. So since this is not equal, this value is not equal, then it has a conflict. We can write down, so functions xy, this continues on 0, 0. That's our conclusion. Okay, I hope you get the idea. Okay. Okay. If you have any questions, just let me know. If no, then we can do we can move to the next page. Okay. I'm not sure which one questions. Oh, next question is this. Okay, try number A. Yeah, the results probably not really in a good shape, good number. Let's try. Okay, let's try. We give you 2 or 3 minutes. If you want, you can also check the second question. But the second question I will skip because it's similar with 15.9 as before. I was just looking for other types of questions that I prepare. But let's say we are starting with the top questions. Okay, top questions here. Let's just put over here. I hope you still remember what's the average value means. I think if you want to start, you can start the second the average value. I think that's maybe simpler than the first one. Okay, maybe I will start with the average value. The average value, if we remember the average value, this is if we take the 0 to 1 fx dx, okay, or this is precisely if we take the 0, 1, the interval, from x to 1, e negative t squared dt dx. Okay. Now solve the inside integral, and I think we could just take some guesses because it's just e, so probably t and then negative t squared. Uh, or even if you want to solve this directly, you could change x and t. Okay, so we could have t is from x to 1 and x is from 0 to 1. Okay? So we could have the, if we could make it ts y and x here. So this is 0, this is 1. So maybe around here that this is the t equal x. Now we could transform, or not transform, reverse the order. Then 0 to 1 for t, and x become 0 to, or t, okay, so x from t to 1, right? Or not from 0, 0 to t, right? 0 to t. So this is from 0 to t dx dt. And I think it's easier to be calculated. And x, or in this case just t, and I think we can directly approach this and make it into, use substitutions, right? Or just guessing, and I believe this is supposed to be easy to be calculated. And we have half 1 over e, like that. Okay. That's for the average value. And for the first one, it's the same similar approach that we have. So we need to reverse the order in order to solve the integration. So we could see that y is from 0 to 1 and x is from 0 to cosine inverse y. So we have the equations that is x is cos inverse y. We could take it into y that is cosine x to make it easier to follow. So we have this is sorry, this is 1, this is 0. Well, this is pi over 2, right? Pi over 2. Let's say this is going to be that. Now we should have the x from 0 to pi over 2, right? So x is from 0 to pi over 2, and y is from 0 to cosine x. Okay, so we could write 0 pi over 2, 0 to cosine x. And then sine x, 1 plus sine squared x dy dx. Okay. And I believe this will be 1 over 3. So integrate with dy, we could have y, so we have sine x cos x. So this will be sine x cos x, and then 1 plus sine squared x, 1 over 3 dx. And then what can we do? We could have, I believe we could just do the substitutions, right? We could do substitutions. So we could take u as 1 plus sine squared x, and du is 2 sine x cos x. And it will be canceling this part, right? Okay. And I think you could take it as your own. Okay. So you could, I believe you can solve this. Okay, you can solve this. Although the answer is a little bit not really in a good numbers. Okay. Well, you could check this also, but I think I will skip this. Well, the idea is because we have the xy, right, equal 1, and x equal 1, and x equal e, and xy equal 3, then perhaps we could take u maybe xy and v is just x, and then you can check the Jacobian, and then exchange all this. Check the region. Okay, what will happen when you change to uv? And I think we can, because if we take xy as u, then we have u is from 1 to 3, v is from 1 to e, right? And then you can use this as our interval for the integrals. And I think you can start to write the answers. Okay. Okay, I will skip this one, and then rather we could maybe this one. Okay, if we still have time, we have at least one or two. I think 2 more questions. Okay, 2 more questions. Because at the end, I would like to maybe emphasize the topics, and also maybe the details on the groupings, okay, for your final exam. Okay, maybe start with this one. Okay, let E be the solid lying in the first octant within the cylinder, x squared plus y squared equal 4. Below the cone, 3 squared of x squared plus y squared. Okay, let me give you maybe 3 minutes to try. It's a good number, so I believe if you work it out, you can get the number. Please write in the chat box, okay? So every now and then, whenever you have activity, like we have the feedback, right? We have the feedback activity, we have some activity in class when we have the offline class. Perhaps you are not really pay attention, but I'm observing of you one by one. So I know some students who are participated in the class. This is for, I know that some students are really active, but somehow maybe not really good in the exam. I believe it's totally fine. It's totally fine as long as the minimum requirement is met. Okay. The idea behind the class lectures and the scoring system is not to make competitions. Okay. It's feel like you competing with each other, right? Who is the first one who got the 100, who got 90, who got 80? It's just a numbers. It's just a scoring system. But the most important thing is whenever you can optimize yourself, okay, with your knowledge and you can apply it in the real life. That's the most important thing. And sometimes we forget, and sometimes the system, the education system, the school, the university may also forget that. So I hope you know what I mean. Okay, so it doesn't mean that if you get like 60, it's bad. No, okay, don't feel bad. Okay, don't feel bad. That is your at least you tried your best. Okay, you tried your best. Okay? Your grade, like in GPA, is just a grade. Perhaps nowadays, industry not really looking on your GPA. Maybe the first impressions, maybe, but later on they will go deeper, not only in GPA. You will be observed in your teamworks. You'll be also observed in your skills, okay? How to solve problems, how to negotiate with people. And because that is maybe they're looking for someone like that, okay? So not always score is always the best way. Not always, okay? Not necessary. Not necessary. Okay. So back to this question. Okay. I think okay, it's better if you are thinking through. Just look at this projections on XY. Okay, if you project to XY, we could see here, right? The one a quarter circle. So then we could have okay. This becomes the upper surface, right? And the z equals 0 here. Z equals 0 becomes the lower surface. So we could take this as upper surface minus lower surface, okay? We could also take this into our cylinder, right? Cylindrical coordinates. Well, it's actually the same thing. Right? It's actually the same thing. It's just the naming that makes sometimes you are maybe thinking that it's difficult to process, but actually they are the same thing. Okay, this is what we are going to evaluate, and this is our E, right? This is our E, the solid E. Okay, now the upper surface is Z equal 3 squared x squared plus y squared. Okay, so we take this and make this upper lower surface as inside integral, so 0, and this will be 3 to x squared plus y squared. Okay, and this is will be x dz, and then let's say dA, and then this will be d. So let's take the region projected here as d. Okay, so solve one, this becomes x, and then let's say 3x x squared plus y squared, and then dA. Now, of course, the second process from this solid is we have the polar. Okay, we have the polar, which means that we are going to convert to polar. We are having 0 to pi over 2 because it's only a quarter. And then we have the radius. If we look this cylinder here, we have x squared plus y squared equal 4. So we will have radius 2. So radius is 0, 2. And then we take the conditions from here. This is r cos theta. This is another r dr d theta. And we will have r cubed cos theta dr d theta. And we split these two. So we split becomes, this is cos theta d theta. And this will be r cubed and then dr. Where is 3? 3, oh, let's forget 3 in bit there. Okay. So this will be cos theta become sine, become 1, right? So we just focus on here, 3 over 4, 2 over 4 minus 0. This will be 16 divided by 4, it's 4, is 12. 12, so the result is 12. Okay. Okay. Okay, this is the last one that I prepare. Find the maximum and minimum for this function. So this is the one that is optimized, and this is the one that is the constraint. I will just give you a clue, and you need to observe by yourself later. Okay. First is, if we take the gradient factor, okay, for let's say this partial x is 6x, partial y is 4y, and we are only having two variables, right? And we have, let's say g becomes 2x squared minus 2xy plus y squared minus 1. And let's say the partial for x is 4x minus 2y, and then partial y will be 2y minus 2x. Okay. So we are going to have Lagrange equations. So we need to solve this, okay, through the Lagrange, and we need to state our assumption so that we are sure that this is correct. And then later we solve some equations throughout the Lagrange. Okay? For example, let me show you 6x is lambda, and then 4x minus 2y. And then 4y is lambda 2y minus 2x. And the constraint, we also need the constraint to make sure that we have some limitations in our calculations. Okay. So first is, maybe we could try to solve through these two first. Okay, we could solve, we can divide these two, and later we can plug this system and check through the constraint, and then checking the possibility of x or y, and then check the point. Okay, so after this we need to check the point and consider which one is maximum and minimum, and that's how we eventually will get the answer. Okay, I would like to just finish off this sessions with just a slight topics, okay, that we will have to, so as we have in our review, that is, we have chapter 12, chapter 13, right? So chapter 12 and 13, although it's minor, we will have a little bit calculations here and there. At least you know the tangent line, not the tangent line, line equations, right? Line equations, and also dot and cross product, okay, dot and cross. But I think it's also related to chapter 13, dot and cross. And also the quadratic surface, okay, quadratic surface, at least how to identify. Okay. And in chapter 13, this is supposed to be I think the tangent unit vector, the normal, the curvature. Okay, at least know how all this will be related. Okay, and I think this will be just minor. You could focus more on the chapter 14 and 15. So 14, this could be on limit, continuity, the partial derivatives, the chain rule, the directional derivatives. And please remember that when we have the limit and continuity, you need to connect this concept to partial derivative and directional derivative because they are basically built on the limit and continuity. Okay. And after that, we have the maximum, minimum. So finding the D, right? The D. The second derivative test, right? Okay. Which one is saddle point? So local max, mean, saddle. It might also have the absolute max and mean. Depends on, I think, interval and then I think the function also. And the last one will be the Lagrange. We'll be still having the Lagrange. Okay. Oh, the tangent plane. Sorry, forgot. The tangent plane. The tangent plane. Remember that we have C. Okay. And chapter 15, as we did, this will be double integral, the Fubini, right? Fubini theorem. What else? The polar, right? Convert to polar coordinates. And then triple integral. Cylindrical, spherical, the change of variable, or Jacobian. Double, triple, and change of variable is a must. Okay. Cylindrical or spherical, this is maybe perhaps one. Okay, perhaps one. Polar coordinate, perhaps also one question. So Lagrange perhaps one. Max, min, one or two. Directional derivatives maybe one or two. The tangent plane is at least one. Partial derivative maybe two. Chain rule one or two. Limit continuity at least one or two. Okay, this is at least what we have, and the rest is optionals. Okay, optionals. This is the primary question. So maybe in one question they will ask several points. It might also be happening. Okay. So all in all, okay, this will be the last lectures. So I hope everyone can prepare the finals. So for the preparations, let me check what we have last time we discussed. Okay, since we are having 120, I would like to have you because this 120 is we start. Okay, we start. Start means start working the final, start the exam. Okay, so I need you to come join the meeting 1:10 at least. This is at least. If you can sooner from 1, that's also okay. But if you think it's too early, you could take 1:10. At this 1:10, I will make a group. Okay, so you will divide into several groups. The groupings just for type questions type. Okay, not grouping in different. Maybe we break the session. No, we just take into groups. Okay, take groups, and then we may start the exam 1:20. Okay, and remember that we will have 2 sections. The first one is quizzes. This will be live quiz. The second one is the flexi quiz that you have using. Okay, and this is divided by questions type. Okay, prepare maybe paper, because you need to write in the paper for some parts that you need to take picture or maybe scan if you want to scan, and calculator if you have. If you want to use maybe calculator in your phone, I think it's okay, but I believe it's better using the mathematical calculator. Is more functional, and it will save your time, right, for some calculation. And you need to fit your answers into what the expectations from the questions. Okay? But if you don't have time, you just can write your idea on the answers in your paper if you don't have time. Okay. If it is just multiple choice, then you need to choose which one that is fit with the answer. Okay. So that's it. Just for preparations. So I hope we could see you next final exam, on the final exam. The same meeting room, this WebEx. Okay. So 9th of June. Okay. So see you on the final exam. Hopefully you can learn and prepare your study. And yeah, I think that's all from me. If you have any questions, any discussions that you are maybe you feel that you need more explanation on some topics, please let me know. I think some of you are requesting some parts of the quiz that need to be explained. Maybe later, after the quiz finish, I will post at least a few questions that I think you are maybe most of you getting wrong answers. Okay, but that will be another additional video. Okay. So I think that's all for today. If you don't have any questions, you can leave the meeting.